Need to create a specialized version of an existing tool without duplicating code or breaking the original? You'll see how to transform a generic search function into a domain-specific product search tool, then disable the original to avoid confusion. The pattern uses tool from tool to customize names, descriptions, and even hide unnecessary parameters, all while keeping the core logic intact. From FastMCP, import FastMCP. From FastMCP tools, import tool. MCP equals FastMCP. Hash the original, generic tool. At MCP, tool. Def search query. SDR category, SDR equals all, list dict. Hash create a more domain-specific version. Product search tool equals tool. From tools, search. MCP, add tool, product search tool. Hash disable the original tool. Search disable. This demonstrates the tool transformation pattern, a declarative approach to adapting existing functions into specialized tools without rewriting core logic. The pattern treats tools as composable layers, where you can modify metadata, arguments, or behavior while preserving the original implementation. What makes this distinctive is its ability to create domain-specific interfaces from generic functions, tailoring them for specific use cases or clients. The transformation works by wrapping the original tool in a configurable adapter layer. You define changes declaratively, renaming parameters, hiding internal arguments, or adding validation, while the framework handles the underlying invocation and schema generation. This separation of concerns lets you focus on interface design rather than implementation details, making tools more maintainable and context-aware. This approach solves the problem of tool proliferation and inconsistent interfaces. Instead of duplicating functions with slight variations, you create targeted versions from a single source of truth. It's particularly valuable when integrating with LLMs or external systems that need simplified, domain-specific APIs, while still allowing you to evolve the core logic independently. The trade-off is a slight indirection cost, but the benefits in consistency and reduced boilerplate outweigh it for most use cases. Let's break it down. From FastMCP, import FastMCP. From FastMCP tools, import tool. Imports FastMCP, the core framework for creating AI-callable Python tools, and tool for advanced tool customization. These are the foundational components for exposing functions to AI models while maintaining control over their behavior. MCP equals FastMCP. Instantiates the core FastMCP controller. This central object manages all AI-callable tools, handles registration, and routes execution between Python functions and AI models. Hash the original, generic tool. At MCP, tool. Def search query. SDR category, SDR equals all, list dict. This defines the base search tool using FastMCP's decorator pattern. The function becomes AI callable with its signature and docstring automatically forming the tool schema, while the decorator handles registration with the MCP instance. The generic design allows later specialization through tool inheritance. Hash create a more domain-specific version. Product search tool equals tool. From tools, search. MCP, add tool, product search tool. This creates a specialized tool by inheriting from the generic search tool, then registers it with FastMCP. The pattern enables tool reuse while maintaining domain-specific customization, avoiding duplicate implementations. New parameters or validation can be added without modifying the original. Hash disable the original tool. Search disable. This disables the original generic search tool after creating the domain-specific version. Prevents duplicate tool registration while maintaining the same underlying functionality through the specialized interface. Tool transformation pattern. The tool from tool method creates specialized variants while preserving the original implementation, enabling domain-specific interfaces without code duplication. Disabling the original tool prevents schema conflicts when both generic and specialized versions share the same underlying logic. This approach maximizes reuse while maintaining clean, focused tool schemas for AI clients.
The tool that forgets its name remembers every purpose